I started recording for information. My name is Syed Ismail. I have visited, I think earlier this year, I think I visited uh, your place, and it was a good time. I had about 2 days time. And today, Parth has asked me to talk about automatic irrigation systems. This is in my soft corner of my life for last more than a decade. Once I re-entered into agriculture, I'm basically a PhD in agriculture engineering. I worked for some time in German university. Afterwards, I'm into business. So my family was not in business. I was the only person to enter into business, and I have made till now probably 50 business people, young engineers. That's my passion. Now, mostly I'm doing on my passionate work, which I am the Secretary General of Asian Association for Agriculture Engineering. Plus, I help a lot of small startups who want to work uh, with the electronics in agriculture domain. So I am in touch with most of the universities, professors, and ICR in India in the recent times. And also, I visited some colleges and trained some students. Now, this is one of the topic very important today, and I will be talking in short. Now, எல்லாருக்கும் தமிழ் தெரியும், தமிழ்ல பேசலாம் என்கிட்ட. Okay. I'm basically originally I studied in Dindikal, Pollachi, Palani, then Coimbatore. So, I can speak very well Tamil. So, கேள்வி தமிழ்லே கேட்கலாம். நான் இடையிலையும் I will also use Tamil words where you can understand clearly. See, this is told by Mahatma Gandhi. என்ன சொல்றாருன்னா, இந்த நிலம் எல்லாம் நமக்கு மூதாதையர் தந்தது இல்ல. நம்ம குழந்தைகிட்ட இருந்து கடனுக்காக வாங்கியிருக்கோம். அதனால போகும்போது அது எப்படி இருந்துச்சோ அப்படியே விட்டுட்டு போலாமே. The earth, the land, and the water are not an inheritance from our forefathers, but are loaned from our children. So we have to hand over to them at least as it was handed over to us. This was told probably 8 years back. We know Mahatma is no more from 1948. So this was told much earlier to that. So I think it's time for us to look back and see how we do it. In that context, automation of irrigation is most important today. You see, today, fresh water, nalla thanni, 90% are used in agriculture. It was 80% before 10 years. Now it is 90%. This year statistics says. Then people will ask me how much. We see a lot of advertisement that a film actor comes and tells the school children to turn off the tap in the schools. Our drinking water household consumption is less than 3%, 2 to 3% only. 90% agriculture, 2 to 3% only for drinking we are using. Then comes rest of the industrial as well as the power plants. So you see the agriculture, we use the water or we waste the water. Now we have 17% of the world population and only 4% of the fresh water. Now you look at other side, people always tell me that we have a lot of groundwater. Bore pota தண்ணி வந்துரும்பா, பிரச்சனை இல்லை. At least 2 to 3 meters per year, the water level is going down. Most of the places. I think in Tamil Nadu, you saw recently last week, there were on climate challenges, what are the dangers, which districts are going to be affected was published last year. It is really bad because of the climate change we are facing now. And that added to our misuse of water, land, everything. Now, what is the rainwater? We use only 48% of the rainwater. The rest of them go just run off. Now, you see in the background, you see the water. This pond was constructed by a farmer and it stores 10 crores of water. It was done about 5 years back in Beed district. He had 7 acres farm. He constructed 1 acre. He supplies the whole village. Our surface water storage is become almost not growing in anywhere. Tamil Nadu ஒரு இடத்துல குளங்களை திருப்பி they're doing public, they're doing some, but not enough. We'll talk about precision agriculture. தமிழ் அதுக்கு துல்லிய வேளாண்மை. What is precision agriculture? It's very simple. Apply the optimum amount of inputs at the correct place and at the correct time. That's all. It is same like நேரத்துக்கு நல்ல சாப்பாடா சாப்பிடு, அவ்வளவுதான். அதே மாதிரிதான் இட்ஸ் சிம்பிள் precision agriculture. We are not doing precision agriculture in India, even to 0.01%. Why this is important? Water and fertilizers. I already told 90% water is used in agriculture in India. What about USA? USA it is only 35% and China 50%. Fertilizer, if I tell the figures, there will be problems with a lot of scientists. I say around 50% we use more, but some scientists argue on 40%. But to me, even 10% is too much. For example, we spray chemicals, even on sugarcane, spraying chemicals. Do you know how many percentage actually of the chemicals go to the plant or the insect or whatever may be? Less than 10%. It's 7 to 8%. Rest of the chemicals, all of them go to the earth, the soil, the water, and the environment. That is today's actually is truth. Another third problem we have salinity. I think in Tamil Nadu also has some part salinity. Andhra has in the coastal zone lot of salinity problem. In Maharashtra, heavy salinity problem in sugarcane areas. Okay, around 7 to 12% of the land is almost non-cultivable because of salinity. Because why salinity comes for different reasons, not because of sodic soils. I'm talking about water and fertilizer application. That brings the salinity up. So we'll reach around 20% in about 20 years. So when you guys become big and your children grow up, you will have wasted 20% of the land. What is precision agriculture? We will see. What you apply: water, fertilizer, nutrients, and chemicals. Where you apply. This is very interesting because when I was there with a team of some, I think it's African, this one in Bisa. So the question was asked to them, who needs water, plant or soil? So everybody has asked, you tell me which requires water, plant or soil? The answer is plant. Same way, which requires fertilizer? The plant, not the soil. So apply at the root zone where the plant is there. When to apply is very important. You eat 3 times. Many people eat twice in a day. And I have seen people eating only once a day. I used to do it also for almost 10 years of my life, only 1 meal a day. So when to eat, what to eat is very important. Schedule. Same way, watering, fertigation is very important. For example, I asked before 7 years I visited in Baroda, a banana farm in a village, complete banana growers. They have changed first from tobacco to sugarcane, then to banana. So very interesting village. I visited because somebody asked me to visit and talk to the youngsters, all our youngsters who are running these farms. So they were telling, I asked them, when do you apply fertilizer? They told once a month. So I asked them, if you eat once a month the food, will you survive? So the fertilizer application also very important, wherever, whichever crop, when we apply. Who applies it? Most of the fertilizer is applied manually today. But now today you have also systems manually with sprinkler, drip, or flood, or with hand. But there are ways to do automatic. So we are going to talk today about automatic. What influences this precision agriculture when you're going to do this? The climate, the soil moisture, how much water is there in the soil already. Suppose it's heavily raining, people still do drip irrigation I saw it in before last year in Maharashtra. They use drip irrigation also. The productivity is less. If you give too much water, output will be less. நிறைய தண்ணி குடிச்சீங்கன்னா வேலை செய்ய முடியாது. Same way the plant also. If you give too much water, it will not produce. Now, what are the water saving techniques we have learned till now? Water saving techniques. Okay, there are things like building dams, and this is different. But water saving with our practices, what we can do. One is called for paddy, especially on paddy, but it comes to many crops. Many crops experimented with paddy. Paddy doesn't require water to be always to be on the field. It is our belief. In the world times, we believe water is required for the paddy. நெல் வயல்ல எப்பவுமே தண்ணி நிக்கும்னு நினைச்சிட்டு இருப்போம் ஹார்வெஸ்டுக்கு மாத்திரம். But reality, it doesn't require. You have to irrigate after the water reaches sometime 10 centimeters or 15 centimeters below the ground surface. Then only it needs water. See, that way you save 30% of water. Now, is this new? No. 20 years we know already. Kharagpur has done work on 20 years back, IIT Kharagpur. And ICR has done a lot of research. But it is not practiced. There are some NGOs trying to work on this, but why it is not practiced, we'll see. It's the same case like our automation also, why it doesn't take up. We have to solve the issue. Next is the root zone irrigation. This I have seen Tamil Nadu and Kerala, many farmers, coconut farmers, they're using a stick like that and putting the drip into the stick. So water reaches the root zone. They save up to 50% of the water. So 50% is very significant. So this is two of the techniques we learned how to save water. Now, you know this all in sugarcane. We have different type of root zone. We have surface drip. We have subsurface drip. Subsurface means it goes near the root. வேருக்கு பக்கத்துல தண்ணி விடணும் சொட்டு நீர். வேறு எங்க இருக்கோ அந்த இடத்துல சொட்டு நீர் விடுறதுதான் subsurface drip. That saves all your fertilizer, water, everything. This all of you know already who are used drip irrigation. It is not still so popular, but it will catch up. Other crops, it has already caught up this drip irrigation. Many of the states like Maharashtra also, mostly it's caught up the drip irrigation because of water scarcity. Now, let us see, we know where to apply the fertilizer, when to apply. எப்ப தண்ணி காட்டணும் தண்ணி பாய்ச்சணும் அது விவசாயிட்ட கிட்ட தெரியும். அது இப்போ நிலத்தை பார்த்தோன்னு சொல்ற நாளைக்கு தண்ணி பாய்ச்சினா நல்லா இருக்கும், இல்லாட்டி நாளன்னைக்கு தண்ணி பாய்ச்சலாம்னு. But how, what technique we are using today? Automation பண்றதுக்கு முன்னாடி we should understand what is available today. What is the advantage? What is the advantage of scheduling? It will reduce the water stress on the plant. தண்ணி இல்லாம காஞ்சு போயிடும், அதை கொஞ்சம் குறைக்கும். Reduce cost of water and labor. Now, people will say water is free, it's coming. It's not true. It won't be for a very long time. Lower fertilization cost. I already told you, we waste a lot of fertilizers. It's the most expensive. We import DAP. That's one of the biggest burden on Indian economy. Increasing crop yields also it will. Because irrigation, you give correct time, it will grow more and better crop. And there'll be no waterlogging problem. Waterlogging problem means salinity, all the stuff. Drainage you have to provide. This all reduces. No need to provide drainage much when you look for this. So now, what are the parameters? எதெல்லாம் affect பண்ணும் இத decisionல? How much water goes into the soil? Soil porosity, எவ்வளவு soil, sandy soil, clay soil, அதனால எவ்வளவு தண்ணி உள்ள போகும், மேல எவ்வளவு நிக்கும், இது ஒரு parameter. Next, how much water is used by plant? The particular plant, how much water it uses. For example, I tell you, 1 kg of paddy requires about 2,500 liters of water. 1 kilo அரிசி 2500 லிட்டர் வாட்டர் குடிக்குது. பிளான்ட் evapotranspiration அப்புறம் என்ன ஆகுதுன்னு காட்டுறேன் பின்னாடி. How much is going through evaporation from the soil as well as the plant, and how much is the projected rainfall, எவ்வளவு மழை பெஞ்சிருக்கு or மழை பெய்யுது, பெய்ய போகுது. நாளைக்கு மழை பெய்யும், நாளைக்கு பெய்யும்னா, so we already calculate நாளைக்கு பெய்ய போகுது, அதனால இன்னைக்கு irrigation பண்ண வேணாம். Africa is practiced very much in some areas, very successful, because probability of 70% is available to you to decide on based on humidity and temperature alone. There are models available. Only temperature, humidity of atmosphere and on the shade, you can calculate the models 70% of probability whether rain will come tomorrow or not. Or you'll know evening rain will come, so morning don't do fertilizer, don't apply, it'll wash away. So Africa is using, India we are not using still. This came to me through a professor about 10 years back. He came, we tried to implement, but it's difficulties I will tell you later on in the last slides. Amount of time water available also important for irrigation scheduling. How much time water is available. Next one is the criteria for scheduling. எந்த டயத்துல வைக்கிறது கரெக்டா. சாயில் மாய்ச்சர் டிப்ளீஷன் எவ்வளவு, சாயில்ல மாய்ச்சர் இருக்குல்ல, அது எவ்வளவு வெளியே போகுது சீக்கிரமா பண்ணும். Plant to plant, what is the requirement? Climatical approach, climate approach is very important, we'll show also now. Critical growth, அப்படின்னா தண்ணி அதுக்கு நல்லா வளர்ற டயத்துல தண்ணி கொடுக்கணும். கொஞ்சம் வளர்ந்து முடிஞ்ச பிறகு அவ்வளவு தண்ணி தேவையில்லை, தர வேண்டிய அவசியம் இல்லை. அது சிறுசா இருக்கும்போது கொஞ்சம் தான் தண்ணி தரணும். So these are all standards we'll see also a little bit. And what is the plant water? இப்ப தண்ணி பிளான்ட்ல எவ்வளவு இருக்கு, இதெல்லாம் பாசிபிள் கிரைட்டீரியா ஃபார் ஷெட்யூலிங். இதெல்லாம் கணக்கு போட்டு சொல்லலாம் எப்ப இரிகேஷன் தேவைப்படுது அதுக்கு. இது பார்த்தோம்னா இப்ப என்ன அவைலபிள் இருக்கு, இதெல்லாம் நான் சொன்னேன் இது வரைக்கும். These are all the techniques of water scheduling. What do we have today in hand? நான் இன்னைக்கு மார்க்கெட்ல என்ன அவைலபிள் or what the farmers are having? There are something like CWRDM is there. Some agencies, okay, I think according to you guys, it's agencies. They tell how much water required. For example, this coconut, areca nut, this graph, you will not see the graph, but I tell you coconut and areca nut, you can find most of the crops water requirements, like 175 liters per day per plant. But when they found out farmers are using, 65% of farmers use less than 50% water only, okay? These are all from last year statistics somewhere. And 14% of farmers only use 50 to 79%. So this is one of the schedules available. They tell you how much water to be applied per plant, when to apply. You see sugarcane, for example. This is from TNAU portal. So you can see from here, in sugarcane, what are the water application. So now, for example, tillering phase level, in sandy soil, every 8 days you have to day irrigation. Next 10 days. Then how much to give irrigate? It's very funny. You go and see, this is what available to farmers. ஒரு விவசாயிக்கு இந்த மாதிரி சொன்னா என்ன புரியும், முதல் டேபிள் புரியுது. லெஃப்ட் சைட்ல பாத்தீங்கன்னா எவாபரேட்டிங் பேன், they call evaporation pan. ஒரு மீட்டர் approximately 1.2 meters diameter இருக்கும், depth about 10 inches depth. அதுல தண்ணி வச்சுட்டு எவ்வளவு அதுல தண்ணி எவாபரேட் ஆகுதுன்னு பார்த்து, so they call cumulative pan evaporation, CPE ratio. இங்க கீழே பாத்தீங்கன்னா 0.75%. இன்னைக்கு 10 நாளுக்கு எவ்வளவு ஆயிருக்கோ அந்த அளவு வாட்டர்ல 50% வாட்டர் நீ இரிகேட் பண்ணணும். அந்த மாதிரி ஸ்டாண்டர்ட்ஸ் இருக்கு. This is the problem why farmers cannot adopt. ஆக்சுவலா நம்ம ஃபார்மர்ஸ்னா விவசாயில பார்த்தீங்கன்னா they will say when they enter the farm, அட கொஞ்சம் காஞ்ச மாதிரி இருக்கு, இப்ப தண்ணி விட்டா நல்லா இருக்கும்பாங்க. But to get that feeling from the data available like this is very complex. யாராவது ட்ரை பண்ணி பாருங்க. But there is something positive also comes. I'll tell you the positive what's available. Computation of water requirements. How much water is you have to apply, this scheduling. You have one expert here sitting there, Parth Gupta. I think I remember him working about 4 years back, 4 years, 4 years back. For 3 years, he was working for another one of the World Bank projects here. and he was computing the water requirement. So I will show you how they calculate the water requirement with computers. So the computers can tell this much water you have to apply at this particular time. This is transpiration is coming from the plants, evaporation is coming from the soil. So they are called evapotranspiration. Evapotranspiration is important parameter. இது வந்து தண்ணி நீ எவ்வளவு ஊத்தினாலும் இவ்வளவு தண்ணி வெளியே போயிருதுப்பா, அதனால அந்த தண்ணி சேர்த்து தான் நீ தான் ஊத்தணும். So that is the meaning of evapotranspiration. So this is the old practice throughout the world. People use evapotranspiration. There are better techniques available. So computer modeling இதெல்லாம் யூஸ் பண்ணுவாங்க. Water, rainfall, runoff, evapotranspiration, irrigation losses, ground water recharge. ஊத்துற தண்ணியில கீழே எவ்வளவு உள்ள கிரவுண்ட் உள்ள கீழே போகுது, சார்ஜ் ஆகும். அப்புறம் ஹியூமிடிட்டி, டெம்பரேச்சர், சாயில் கிராப், பிளான்ட் வாட்டர் கண்டென்ட், இதெல்லாம் ஒரு ஃபேக்டர். எவாபோட்ரான்ஸ்ஃபர் அஃபெக்ட் பண்றது என்ன? ஹியூமிடிட்டி, டெம்பரேச்சர், சன்லைட், சோலார் ரேடியேஷன் அண்ட் விண்ட் ஸ்பீட். நிறைய காத்து அடிச்சாலும் it will go away, water will go away. Now there are solutions available. You see, this was done probably 1 year back. I took this data, or maybe 1.5 years. So we have the SAT data, that is Landsat. Landsat gives you data up to 30-meter resolution. Every 30 meters you have data saying that what is the water requirement based on the climate. But whether it is used by farmer, this is our question. This is available 30 meters. There are problem challenges bringing it to the farmers availability. இப்போ உங்க ஃபார்மர்ட்ட போயிட்டு இந்த மாதிரி டேட்டா இருக்கு உங்களுக்கு தெரியுமான்னா என்ன பதில் சொல்லுவான்னு கேட்டு பாருங்க. Another one is there are programs. This again 2-3 years old. These are all 3 years old. Full irrigation scheduler. This program is given. There are disks available. You can load it on the desktop. You can find out automatically. இங்கே நான் எழுதியிருக்கேன் how many attempts are done by industry and the research institute. It doesn't come out. ஏன்னா நான் இது வரைக்கும் ஃபார்மர்ஸ் யூஸ் பண்ணி பார்த்ததே கிடையாது. நிறைய ஏதாவது 1-2 இருக்கும், but it's not. See, we are talking about lakhs and lakhs of farmers. Is it feasible by Indian farmers? This is our challenge. We learned this today, whether it's possible for us to use it. Water or fertilizer, measurement and control. இதுக்கு என்ன தேவைப்படும் காம்பனண்ட்? இவ்வளவு பேசுறீங்களே, என்ன தேவைப்படும்? எப்ப வாட்டர் கொடுக்கணும்னு பார்த்தோம். There are some issues when to give water. So maybe I can take it also some rough image. Farmer says, I will give him tomorrow. Okay, we use that base and let us work on how to get from the computerized data to the farmer level. But அது இருந்தாலும் how to apply? How will we control it? One of the concept is people say, and you will see a lot in YouTube and lot of people, soil moisture measure பண்ணி எவ்வளவு soil தண்ணி இருக்கோ we put it. This is really a hype. Don't believe it. It's happening today. It's only happening in the internet everywhere else. Maybe in a form when you buy, you may use it 1 month, 15 days, not more than 3-4 months I have seen working. Because there are different type of sensors you have. Like you took about capacitive sensor. நீங்கெல்லாம் கவலைப்படாதீங்க சொல்ற terminology, no? Capacitive sensor. Then there is TDR sensors. There's time domain reflection. Then you have FDR sensors. So different type of sensors. But none of them are accurate enough for the soil measurement. பிரச்சனை என்னன்னா, we have to measure a different depth the soil moisture. It's not one place. Our crop root zone is going from one to another, maybe 10 centimeters, 15 centimeters. We have to place it correctly. அப்புறம் land அவ்வளவு ஈவனா கிடையாது. So you have to have multiple sensors. So I worked with one of the place in Bisa for the sensors they installed completely around 50 acres farm about 7-8 years back. I will share with you the experience. So right now, soil moisture measure பண்ணி irrigate பண்றது practically not possible. With research level we can do, but not farmers. I cannot ask lakhs of farmers use the soil moisture sensor, it will work. That is not possible. Water level, we don't have any measurements at all. See, most of the irrigation is done by dam, canals, or you have the water tank, water tank, bore well, everything. But there is no measurement. We don't know how much water is available. எவ்வளவு தண்ணி இருக்குன்னு நமக்கு தெரியாது. So we have to measure this one day or other. May not be high priority, but once we start controlling water, scheduling water, you also must have system for measurement of water, how much water we have. Important thing, what is the important thing is, see, I will give you example of the same banana farm I visited. The banana farm, one farmer was asking, he is having 4 of the laterals, which means his farm, he got 4 walls. The water is pumped from the river near Baroda, it is near the river, up to 5 kilometers to the village. They have got a big pump, and it pumped, water is lifted from the river and brought to the village. In village, they distribute the water among different farmers. பிரச்சனை என்னன்னா, night time only they get the power. So night time, one farmer goes and waits there, starts the pump, and then he gives to one farm. Then after half an hour, he switches to next farm. Now, farmer goes, one farmer knows, he goes to farm. He has got remote control, pump starting, everything from here. Actually, from he has bought it from Coimbatore. I saw it from Coimbatore. Actually, Pune also has. So very good system. But he says, I have to go and switch from one area of the farm to another area of farm water. So for that, I have no solution. Manually, I have to go and change the valves. And that is where the control comes into picture. In automatic irrigation, we have to shut off the water supply to one part of the farm, one section of the farm. Because if you have 1 acre farm, you cannot have only one. You will normally divide into 2 or 3. 2, normally it is done. If you have 2 acres, 3 acres, then you'll have 4, 5 divisions, because one pump cannot supply to all of them at the same time. So this switching, we use valves. You all must be knowing solenoid valve, electrical valve. Yes, but these are still imported. They are not, even though Indian companies, all they say, but they are all imported. Because the volume is requirement is very less requirement. They are not in lakhs. So most of them imported from China, but either from US company name, whatever it is, but ultimately locally Indian companies sell it. So these valves, there are different type of valves are there. பிரச்சனை என்ன வருதுன்னா, what you will do, if you put valves in the field, how will it get power? So I know one of my classmates himself, about 8 years back, he installed in Coimbatore, a big farm. He installed the valves, he put the wires, pulled through, wire got cut, and that time rodent problem. Then we put again rodent proof cable, still it was cut. So the problem comes with, we need a solution without wire. Otherwise, it's not practical to use in the farm. It is possible, and you have the latched valves available. Latched valves are only slightly expensive. Now, these valves are the main part, which really, one of the main part, which affects automatic irrigation control. For example, the valves we use normally is 2-inch in agriculture. I think if you know it, 2-inch, 2.5 inch. Normally 2 inch will sufficient, 2.5 inch sometimes. Not more than 2.5 inch normally we don't use. We don't use 1 inch. 1 inch is normally for garden and everything. For agriculture, 2 inch, maybe 1.5, sometimes they use inches of valves. So this 2 inch, 2.5 inch valves comes around the cost of 6,000. But actual manufacturing, if somebody starts manufacturing, let's say 50,000, 100,000 valves, probably the cost will be 2,000. So this nobody has taken step. All these irrigation companies, they only make pipes. They even don't make pumps. They buy from some other pump supplier and supply. If you have seen the big names, we know all the big names. And most of them we know from Netafim, from Jain Irrigation, now recently Rivelis, and even Mahindra in the game for quite some time. So they all only make pipes and basic stuff. They don't even think about doing these important things. Automatic irrigation controls we come. So here I will show you how to make automatic irrigation control. You all know part like filter is required. Or filter எப்பவும் irrigation, எந்த irrigation system போனாலும் filter இருக்கும், because you cannot put some dust into the water. It will clog the drips, or even sprinkler it will clog. So you need a filter. Pump you need, and dosing injector. Left side is there, for example, one of the manufacturer dosing injector. That means water is going, water jet is going. You add on the sidewise a venturi flow, a chemical, whatever you want. That chemical get added to the water and goes. It's like who are spraying actually. Spray painting, if you know, it's also the same principle. Air is going, with the air, the paint is mixed together. So same way you mix with the water, that's called injectors. So you have pump injectors or you also have normal venturi injectors. Relief valves, the pressure is high will come. Main lines, lateral lines, dripper. Okay, these are all made by everybody. Okay, most of the companies make it, the biggest companies. So with this, all these things, the cost comes to around 30, 40,000, goes up to 60,000 rupees per acre in the farmer in India normally. Per acre, drip irrigation to put good drip irrigation may come to maximum 60, 70,000. It can be as low as 30, 35,000. But down when you go actuator, the valves and how to control the valves are very expensive. And how much the farmer wants them to be, with my talk with the farmers, they expect 20, 25,000 it should cost. So that means their target is around less than 1 lakh rupees per acre to spend. Then you can think of probably hundreds of thousands of farmers getting into this. I'm very sure also will come in every crop, whether sugarcane or any crop. This is one of the things which I made actually 5, 6 years back. The wall, you can see the wall here, the big wall, 2-inch wall and 1-inch wall you can see. And you see this much only is electronics required, very small electronics, and this is a battery. Only with the battery it can go for a month without even solar panel. And when you have the solar panel, it can go forever. And it's not a cost. And how it will come in, no wires. So this will communicate wirelessly. And I will explain you some of the techniques available, but not available with any of the manufacturers. The big manufacturers don't bother about it, or they don't give it, because the people sitting there on the top are ignorant about it. They don't know knowledge. I think you youngsters must ask them, this is available, why you don't give it? Because then only they are looking only at the mass production, that's the pipes. So this is one of the requirement of how it will look like for you have got, for example, 10 walls in the farm of 5 acres, you will have about 10 walls, probably, or 8 to 10 walls, you will have 5 acres. So that to control probably 3 stations you require, or 4 stations of such a one, and probably the total cost of what I told the figures, it will come much less than that. But the big company is not adopting. Now, this is the one which he adopted about 788 is 19, I think 2018 in Biza. I gave them this system to use in their 50 acres farm. And this is how the computers give result, completely scheduling and whatever water level. Now, I think when coming close, we talk about irrigation control, what is required. Very simple. We require valves so that it can be switched, and we require the valves to communicate. So we require 2 parts only, nothing else. Communication. The valve must be get a command when to open and close. And how much water to put, everything is secondary. They are like preparation. But without this, you can't do anything with that. So because we already have resources available for finding out how much water to apply, how much fertilizer to apply, when to apply. But we don't have delivery mechanism. We don't have it because nobody thinks about it till now. But I know there are. Last year I was in Delhi also. One small company was trying to work on it, this type of system, but he got no support. It was an ICR meeting and I was there. There was no supports at all. So my question, this is the end chapter I'm asking, the implementation challenges of this automatic control in field, what I'm talking about, agricultural field, whether it's sugarcane or any crop, is not, people say, if you ask them, they say there are some available. I will tell you, I visited 10 years back also in India. 2 locations I saw automatic controls working. Okay. But then this particular one chapter talks about whether it's practical or it's a hype. First, I see the challenges in the field. When I look at the field, the system what you use in field, this is one of the form, okay, which is I think it's done by one of the IIT guys again who was apprentice. I think Parth knows him, Setu Garge. He is the one who made this map. is ASP form here. So how the valves are located, the irrigation valves, where it located, where is the pump, everything. This is Google Earth. It was done. Maybe 5 years back it was done. It should be rugged and it should be simple. It should withstand harsh environment. You must know rodents and animals are there in the farm. So anything you install must be tolerant to this. Theft, people steal it. Okay, for example, solar panel, if somebody sees, they steal it to put their lamp they think useful. So how to avoid? Power outage, there'll be no power for days together. Lightning is a big problem. Bisa had this problem. When the lightning comes, all the wires, everything suddenly will blow up, or it may not blow up, it gets damaged. You will know it's not working after 3 months. Suddenly it will stop. This is a problem with lightning. So you must have, and don't tell me that lightning arrestor, if you put it will work. No, it's not so simple. But there are techniques available. So the people who design the systems must know about the threat of lightning, how it can affect. Networking, how these valves will be connected, from where the command will go, how it will reach them, this networking. Now we must remember in farms, there is no poor access for service. Anything goes wrong, no service engineers will go in 24 hours. So this has to be considered. And the last point is the return of investment. Whatever farmer pays for it, he must get within 2 seasons. Otherwise, he will not buy it. Don't think it's like a tractor. It's not a tractor. For him, 2 seasons maximum, he'll wait for 3 seasons. So return of investment is important for this. These are field challenges. Communication for this, there are a lot of techniques. We used also some of the communication I'll show you. We used low-cost communication available, hopping technique. That means from one person to the next person, next person to the next person. Like this, you can go for even kilometers. But today, recently, I worked with for a Brazil company on NTN, that is the non-territorial network. Satellites communicating directly. They're not expensive. India has not come yet. But I think the same type of country, Brazil, adopting very fast, and we are getting slow in this field communication. We know, but actually, I'm trying very hard in a lot of forums to talk about the village level communication for the farmers. A farmer cannot buy 20 SIM cards to put in different places. So this is will go on. I will continue fighting for this. Now, what is the status of automatic control in India? The cost approximately 4 to 6 lakhs, okay, per acre. Now it could be even 8 lakhs. Starting from the name, you ask the quote, and nobody gives you quote like this. They will tell you your field, they'll come and survey, and then finally they will give a quote. But normally 4-5 acres is around 25-26 lakhs. I have seen the in Nasik area, you got farmers make a small pond, pomegranate grapes they grow, and they have a lot of them. I in 10 years back, I saw about 10, 15 were there in Maharashtra. And when I hear a bit after last year, when I was talking to people, the companies, most of the company people, I know them, they told maybe 200 we installed, 250 installed. So I think probably 500, 600, maybe less than 1,000 throughout India, the installation, which are working today, probably much less than that. So I think the growth of 10 years is very less. The reason, number one, cost. Number two, all the irrigation companies are interested only in basic irrigation supply. And the technology can bring only from the small scale industries, and they don't get any motivation. For example, this particular device I can give for your sugar institute or sugar industry, for example, first to cover for 10 acres. I can give it free, the system. Problem is I have to send a person, technician, first trial, and person must be there. This cost will become prohibitive. So any of the development of this type of systems, only small scale industry do, and they don't have the support of anybody. For example, including for a joke, I'm telling, if IFC, I ask for a fund for a project, they will not give me. Even they will not give it to my association. They will not give, because they will look for corporate, big companies. This is the big problem we are facing. We want technology in agriculture to come. We have to promote small companies. First is trust is not there, because we know it. We buy only if it's from Mahindra, but I know what is happening in Mahindra. And I know exactly what happening in these big companies. Only those guys who work with the corporates, they know. And people also prefer to work in corporates, not in small companies. This is a mindset. So trust is lacking from public, and up to the top level. We have to change that. Number two is the finance. Small companies go, you won't get finance. But if you go and ask for 10 crore, 20 crore, I remember World Bank, I was talking casually to a guy, he told minimum 10, 20, 100 crore, we don't talk less than that. So this is what is the status. And India is one of the biggest lender of the World Bank also. If you see the, not only World Bank, I'm talking about Indian Bank. You go to any of the bank, they will not give you funds easily. This has to change. Now the government is trying to change, but still it's very tough because I know I've been in business all the time. Support, industry support also. It's not there. Suppose I go to a small industry. I have one guy I know, Delhi. He wants to come, for example, to the sugar industry. He want to do it. They won't agree. They will first ask how much cost. Okay. And they'll give 1 lakh only I'll give. But they won't bother to spend lakhs, 10 lakhs, 20 lakhs, 50 lakhs for a corporate. This mindset we have to change. Then only I think the automatic control will come probably in the next 5 years. We can see some changes in India happening. If something start moving, somebody realizes and visits the installation. I have visited Netafim installations 10 years back. And I know now in Nasik itself, probably 20, 25 there around the installations. And I think Jane is doing for last 5 years. And Revelus I have not seen still. But as Mahindra, they buy from one guy, and I know that guy, and they're not much sold. So the problem is these companies, they give contract to small people, and if the fellow sells only 25 pieces or even 10 pieces a month, he will not survive. This is a basic, it's a chicken egg story. So I think the corporates are very important. The big companies are important to be a part of this, the support they have to give to the small scale industry. I think with this, I will stop my talk. I think I've taken enough time, more than enough time. I will stop this presentation and we can go for any questions you have.
Anybody any question? I will.
Feel free to ask any questions if you have.
If you don't ask any question, I will take one of the two things. One, that we understand everything, we are fully convinced with this, and we have fully understood it, and that's very great. And one thing is that we did not understand it.
So actually, we are already started that autonomous irrigation systems.
You are convinced?
Yeah. So we have already started the work.
Yes.
So
You have been doing drip irrigation for men. You know that 12 years back we did it on a very large scale.
Yes.
In Pen.
Actually, two things we have to do, and we have to look into that. One is cost price, it is very high. One is the cost wise, it is very high, sir. Actually, another one is the solenoid valve. When each and every plot you told that there is some around 4 solenoid valve is required for the 1 acre of land. But that cost is also very high. And then another thing in Kodur concern, actually that land type and all, it is not nearer to the one and another field. Actually, there is a distance between the field itself. So each and every, but they came to know that one gateway is required. Actually, it will cover 3 kilometers. But from one field to another field, some part of the beta also, the half of the our command area is very distance. Actually, that is more than 10 kilometers, more than 5 kilometers are there. So it is also very difficult for that, because for that gateway cost itself comes around 1 lakh rupees, it seems. So these are the difficulties. Even though our team is convinced the farmers to come for autonomous irrigation, because our management is negotiating with that company and given some reduce the cost. Is it so, Rajeev? Yes. So these are the difficulties. Anyhow, we are now we are trying to convince the farmers to come forward for the autonomous irrigation. But it is very difficult, but the cost is very high. Then one more thing is the distance between one field to another field. Is that the
Yeah, I will explain that distance is not an issue because you have a LoRa technique available now up to 6 kilometers. And open air you can go long. This is without any SIM card. Because to turn on the wall, turn off the wall, if it takes 2, 3 seconds, 5 seconds, nobody bothers it. It's not like your cell phone. You want so much data. So there are many techniques. Probably the company is not aware of it, but if you tell them, they should be able to provide it. So I don't think distance is an issue nowadays. And if at all distance is a problem, you use a 4G module and it will cost hardly monthly 400, 500 rupees to you. In both the places, maybe 1,000 rupees. That's not a very expensive. And communication equipment for two big farms is not a problem, 1 lakh paying. But the question is inside the farm, for the walls, you cannot afford to put cables. That you avoid it. It must be wireless and the wall must be actuated by only by battery, not by wires. Because long running, I have seen when the people lay wires down, after 3 months, 6 months, you know the problem will start, not immediately. After one season harvesting. So don't lay the cables on the field.
then actually one sensor is enough for the 2 to 3 acres of land, sir. One
What
soil
sense?
soil moisture sensor.
It doesn't work. I told you it doesn't work because you go to the field and walk, you will find 10 places different soil moisture with your
Yes.
leg. Then how can we see whatever people tell technology, we should use common sense. It's not common sense is not possible how sensor will tell. So these are all people hype, youngsters they create, or somebody doesn't have a domain expertise, they create this type of thing. You don't require soil moisture. What I suggest is you tell the farmer decide when to irrigate, no problem. How much to irrigate, you concentrate.
Yes.
Follow the scheduling, that's enough. No need the soil moisture goes automatically, it will irrigate. Don't do that. Never do that. It will not be possible for you. If you do it, you will suffer. So do it once you are sure about soil moisture. First time you record everything, na? Soil moisture, what it commands it gives, when to irrigate, and then find out. You will find out what I'm telling. Okay. But don't put the soil moisture trigger, then they will say there's some blame with the sensor, and so it doesn't work. You lose the crop. No sensor, don't use it. I won't recommend at all.
Because actually 2 months back in one places I saw that in the phone actually that farmer has shown to me. Actually around 6 plots are in the field. And the previous day he got some adequate rain also. But the 4 plots it showed that 100% of soil moisture. That fifth or sixth plot it shows only 80% and 67%.
No,
So
no. Madam, this is the problem with the sensors. The people don't understand the technical. I'm purely technical guy. I'm telling you, they don't work. You want explanation? I will explain you technically. Because for example, if when you use what type of sensors you are buying, if you want to buy the best sensor, I will give you, which works almost okay, 70-80% level, and they are costing around $450. Okay,
yes,
I've shown the picture also, and I think. In Ludhiana, he has seen also picture. They got purchased around 50 of them, but $450 each one of them. And our farmers cannot afford to that, and still only 70% is the reports. So let's forget the sensor. Let's look at somebody tells a farmer says you irrigate now. At least you find out how much to irrigate, how will you irrigate first. You without doing that, we look at sensing only here. Okay, I think sensing you leave it. Rest of the things you sort it out.
Sir, this is a very good technologies and adapt to all the farmers. They are very interested, sir. Only for price, sir. The cost of cultivation is already exceeding.
I told you price is possible to bring 1 acre within 25,000. But I'm telling you the problem is there's only small companies can bring. You go to the big companies, it will not come. Okay. The small companies, nobody wants to go for it. This is the biggest problem. So you have to see to couple of companies I can tell they can give you the solutions, but they're not big companies. So teething problems they have, you have to go with them. It's not a question of you see when we are looking for investing for about 200 farmers, 100 farmers, look at the volume of business what they're going to get total instead of one. So you put your own person, one person, to understand the technology instead of believing on the supplier. And it's not very difficult to understand the technology. That I can tell you, it's not difficult. With that, I
Dr.
think
Shetty, one
probably
very small query, with Parth wants to know it, I mean, through me, that
yes.
has anybody worked out the economics of this? I mean, investing even 25,000 for that measurement or indicating when should we irrigate it, and what's the return over investment on this?
Okay.
Forget
Yes.
who is it investing into it. It may be
No, no.
farmer's money, it may be IFC money, it may be a client money. So what is the return on investment ultimately?
Okay. The return of investment, when it's the same question when I come to cluster of farmers, return of investment, number one, night time they did not go for irrigating the other crops because other places only electricity coming in the night. They told it's the biggest blessing for me and I don't mind paying. How much I'll pay? He told 2 seasons I must be able to get the money paid off for this. So number one is that he doesn't have the problem of going and doing it. Number two, when the fertigation, he doesn't do it now with the drip because fertigation he has to do it in the daytime. So he does manually the fertigation. So when you want the fertigation also to be done in the night, then possible only with automatic. So when you do with the automatic, the cost of labor you can calculate, but that's not significant. Like you say, the return of investment. So that's the reason when you
No,
look at the benefits. Listen. I will
spent on
complete.
drip
I will come.
irrigation is different.
I will complete because we know water will be used less, so plant growth is more. TNA portal gives you using this system, this type of water you apply. What is the return of investment? Okay. From there only we can take the figure of how much return of investment comes using this technique, whether it does manually or automatic. Now manually is not happening. But another point you to ask me, how much to irrigate scheduling? The scheduling has to be again done with your experience and the data available given by the universities or research centers. This has to be done. The scheduling is software imported from Israel. Some people import from Israel, like Bisa imported from Israel. I know the scheduling software. So scheduling software, there are Australian. I know one person from Australian company gives the scheduling software in Maharashtra.
Actually, sir, anyways, so I think going forward, we have to move towards autonomous irrigation because many farmers, now youngsters are coming into cultivation, like many IT guys are coming and in the coming years, if the youngsters are now coming means they need, once we go with autonomous irrigation, they need not go to the farm for irrigation purpose. That is one thing. And definitely they will appreciate the IoT based techniques. Second. And one thing is when we go adaptation is more. That is number of farmers are coming forward for this kind of technology. Then automatically cost will be reduced. See any new technology when it comes, it will be definitely costly. But slowly when more number of farmers are coming forward, then it has to be
The
the
cost will
cost
come
will
down.
be, yeah. Otherwise, continuously now we are we know very well, and still because in Tamil Nadu electricity is free and the water is free. We are just like that. We are irrigation. We are giving irrigation to the fields. So that one way, if you control the irrigation, then only our crop yields also will improve, sir.
Great.
Good.
I think it's you're doing already. I think I cleared doubts. Think about main points I told. What are the risk points? So that's all you have to know. And go ahead. Because
Very
we are spending we are wasting 90% of water. Okay. And none of us can ask about what is not important for a citizen. So I think it's more of than ROI. I'm thinking of the saving of water, saving the next generations. I think that is what we have to think also. It's our commitment. Uh, I think it's not very difficult. Like I told you, if 25,000 per acre costs additional money, a lot of farmers are willing to do it. But this can't be done by a small company. It has to come with some big investment, somebody from investment not big, few crores of investment. Somebody must think, see the wisdom in it and come to it. But unfortunately, the whole technology jargon is coming to agriculture only the recent times, especially the farmers are not well off. So that is the issue. Well, we'll fight through it.
Sir, actually, can you please send the address of that company, sir, to Dr.
Yes,
Rajesh?
I will.
Sir,
Yes,
so that, yeah.
I will share. If there is no more questions, I think
Sir,
we can.
thank you very much for your wonderful detailed presentation. It was very useful for our team, and really I would like to thank you, sir. Maybe I also from DNA, sir. Of course.